Let's set up a Kubernetes cluster in Azure using acs-engine and the acs-engine Yeoman Generator. Get started by running npm install -g generator-acs-engine. This will pull the Yo generator down onto your local machine. Next, you'll need to create a service principal inside of Azure, and service principal enables services to access things inside of your Azure subscription using a username and password. So we start by popping in the subscription ID, setting the Azure subscription we want to create it in, and then running the command Azure as add service principal, which will go and create the service principal in Azure, and then give you back a piece of JSON that contains the information in the service principal that you'll need. The two fields you'll need are app ID and password. So copy this somewhere and save it for later. Now run the actual generator, so Yo acs-engine. Make sure you enter proper numbers, unlike this example. So I'm going to rerun it. Entering one node for Windows and one node for Linux. Choose a DNS prefix. This is what the cluster will show up as in Azure. Copy in the app ID from the service principal you just created, and then copy in the password as well. Now copy in the subscription ID for your Azure subscription. Now type in a resource group name. Try and create a new resource group if possible, because later on you might like to delete the cluster. Now run PowerShell/1 generate ACS template, and this will use the actual ACS engine to generate the deployment templates, the ARM templates that are sent up to Azure. Now we're going to open Visual Studio Code and just have a bit of a look around at what's being created. There'll be a keys folder that contains the passwords and SSH keys that were automatically generated. There's the build.acs.json, which is the actual ACS JSON file that's used to configure the ACS engine to go and build the ARM templates. And you can see there's username and password in there, as well as the two agent pool profiles, the Windows and the Linux pools there. Ordering is important. You must have Linux pools first, or else the Linux pools will not be visible on any services that are exposed. Next, run PowerShell/2 prepare account, and that'll go and create the resource group. And now we run 3 deploy cluster, which actually goes and executes the ARM template on Azure and creates the Kubernetes cluster for you. I've opened up another tab here. I'm going to run PowerShell/4, which actually sets the Kubernetes configuration environment variable, which allows kubectl to use the configuration that was set by acs-engine. And here you can see we're getting the nodes and we're just waiting for the Windows node to come up. But we can see that the Linux agent node has come up. So let's run kubectl and apply the Windows and Linux configurations to go and send some pods up into the cluster. You can go and investigate those files and you'll see that each one has a very simple container in them, that they target the agent pool type of Windows or Linux, depending on what it is. They have a service that gets exposed publicly, and so we can see here, we can get service to see the public IP of the Linux service. The Windows service still hasn't come up yet. It'll take a little bit longer. If we grab that IP address, we can see that there's an ASP.NET Core app running in Linux that's been deployed into the cluster. If we go and wait a second for the Windows container to come up, we should see that it'll be up in a second. It's still just creating at the moment. We can see that the Windows service now has a external IP. If we copy that and paste it in, we should see that the Windows service has come up, and that's actually a classic ASP site running with COM+, 32-bit mode code, all sorts of things. The cluster might take a little while to come up the first time, but once you redeploy a new revision of that Docker container to your container registry, and then go into the kube YAML file and replace the container image, and then reapply that configuration to the cluster. It won't take as long this time for the container to come up. In fact, very similar containers should take 10 to 20 seconds to come up. In this case, the container that I'm applying is a little bit different, so it's got to pull more, a larger container image from the container registry. But we'll see in a second that the container does come up in about 30 seconds. And this V2 of the website basically gets brought up in another container, another container instance before it's swapped out once it's running. So here we can see that the version 2 of the app's come up. Now in real time, I'm going to change the container back to the old version. I'm going to apply it. And then we're going to see the container switch back to the original version in about 10 seconds or so. So important to note, Windows containers are slow to come up the first time, but then they're very fast to come up on subsequent updates.